Hi there, intermediate algebra students. Time for another lesson on solving equations, and they keep getting tougher. This time 3-5, solving equations with a variable on both sides. So as you can see on this one, we have the variable c on each side of the equation, but of course our overall strategy remains the same. We still want to get c by itself, all the numbers on the other side of the equal sign. So once again, the strategy or the process is not really too much different. We always look to simplify things on each side, so there's really nothing I can do on the left nor the right. So then I'm going to work on getting my variables all on the same side. Often it's customary to try to get the variables on the left side, and we'll do that most of the time, but just for variety's sake, let's try to get all my variables on the right. So I'm going to start by trying to move this 5c to the other side, so I'm going to subtract 5c on both sides. Remember, whatever you do to one side of the equation, you must do to the other. So then I'm left with an 8 here. My c's are all gone on the left now, so I just have an equal sign. 7c minus 5c is 2c, and then I still have the minus 2 on the right as well. Now I need to get all my numbers, or my constants, on the left. So I think you can see now that I'm going to add 2 to each side like this. And so then I'm going to have 8 plus 2 is 10. Equals 2c, and now we're down to a single step equation, so I'm going to divide both sides by 2, and sure enough then you see that I'm going to have c equaling 5. That's my answer. I can check that answer by putting 5 back in place of c, and 5 times 5 is 25, plus 8 is 33. I'm just going to jot that down that I got that on that side. On the other side, 7 times 5 is 35, minus 2 is also 33. So 33 does equal 33, and so we did get the right answer. Alright, we're going to move on to another one here and do some more problems. So here's a tougher looking one because it has some parentheses. As I said before, we do want to simplify each side as much as we can, so I'm going to go ahead and use the distributive property here. So 3 times 5x is 15x. 3 times negative 4 is negative 12. Now notice I have another x on the right side, so as we said before, if you can simplify one side as much as possible, that will help. Now 15x minus 10x is 5x on the right here, minus 12. Then on the left I have 5x plus 5. Now something might look a little bit curious to you at this point, but let's just keep going. This time let's get all my variables on the left side. So I'm going to subtract 5x from each side, and this looks rather odd because all my x's cancel out. 5x minus 5x on this side and the same thing on the right. So what I have left with is 5 equals negative 12. And you might say, well, what in the world is going on there? All my variables have canceled out, and I end up with this 5 equaling negative 12. Now, whenever this happens, one of two situations is the result. We say that there is either no solution, or perhaps maybe everything could be a solution. In other words, no matter what you put in for x, it could work. But in this case, when you have two numbers and the two numbers do not equal one another, then what we have is the case of no solution. No solution. No matter what you try putting in there for x, it will not work. It will not satisfy this equation. And that always happens when the variables cancel out and the numbers that you have left that the equation says equal one another really don't. Alright, let's move on to another and see what happens here. Notice this is quite similar to the one we just did. Again, we're going to try to use the distributive property here. So 3 times 2n is 6n. 3 times negative 1 is minus 3. We have a minus 7 over there as well. And then 6n minus 10 there. Alright, so now I'm going to try to simplify the left side. I notice that negative 3 minus 7 is negative 10 or minus 10. And I have 6n minus 10 here. Now already you can kind of tell that we have the same thing on both sides. 6n minus 10 equals 6n minus 10. If I finish this out and do as I normally would, I'm going to get all my variables on the left. Once again, they all cancel out, and what I have left then is negative 10 equals negative 10. Sort of like what we did the last problem, except now we have a different result. Now we notice that the negative 10s are both the same on each side, and so thus this is an equation that we say has an infinite number of solutions. In other words, no matter what you put in for x in this case will work. So that's a unique kind, and I wanted to show you those kind of problems, that one that has no solution and one that has infinite solutions. Alright, now let's continue on. I have one more type of problem I would like to show you. This is where this type of equation could come in kind of handy. Here's some actual data from a few years back. As you might guess, the age group, younger age group, a greater percentage of them have internet in their homes, and that's growing at a rate of 42% per year. And the older folks, such as myself, have not quite as much internet access, but notice that their rate of growth per year is increasing. I'd like to know how many years will it take for these two groups to equal one another in terms of the percent that has broadband internet. So I can write a little equation here. For the younger folks here, it's going to be 52.5, that's what currently have them, plus 42x, x meaning the number of years it's going to take. It grows at 42% per year. I want to know when is that going to equal 25.5 plus 52x. Similar problem to what we have done before. This time let's get all my x's on the right. Sometimes as you do this you'll want to try to set it up so you have positive x values. Here's one of those times. So what I have left now is 52.5 equals 25.5 minus 10x. Now I'm going to add this 25.5. I'm running out of room here. I'm going to add this 25.5 to each side. And so what I have left now, oh excuse me, I made a mistake here. Good thing I noticed it before you guys did. I actually want to subtract 25.5 on each side, don't I? And so when I do that, I believe I get 27 over on this side. Meanwhile, that equals 10x. And so I've run out of room, but I think you can visualize what's going to happen here. Now I'm going to divide both sides by 10, and x is going to equal 2.7 is what x is going to be. So that tells me that in 2.7 years, these two age groups will both have the same percent of broadband in their homes. Alright, thanks for listening, everybody. We'll talk more about this in class tomorrow. So we'll see you then. Bye now.